Now we'll look at solving radical equations. So we're going to start by looking at the power rule. And so that tells us that if both sides of an equation are raised to the same power, then all solutions of the original equation are going to be among the solutions of the new equation. And so we're going to use that when we're solving our radical equations. So here are our steps to solving. So the first thing we want to do is isolate one radical on one side of the equation. In most cases, there's only going to be one radical, but sometimes you'll have more than one. But we always want to start by isolating one radical on one side of the equation. Then our next step is going to be to raise each side of the equation to a power equal to the index of the radical. Remember, the index is right here. It's whatever number is right here. And if you don't see an index, it's an understood 2. Okay? If the equation still contains a radical, then we're going to repeat steps 1 and 2. If not, then we're just going to solve what the equation we have. Then we always want to make sure we check the solutions in the original equation. All right, so let's look at this and see what we got. So question 1 says the square root of 3x equals 6. So our first step is to isolate. Well, if we look, we think about this as two sides of an equation. I've got my square root isolated. It's already by itself on one side of the equation. Remember, we've got that understood 2 there. So to get rid of this square root, I'm going to square, raise both sides to that second power. Because since the index and the power match, this will cancel with this. And so what I'm left with now is just 3x equals 6 squared, which is 36. And now I've got a pretty basic equation to solve. I'm going to divide by 3, and x equals 12. And then my final step just needs to be to check it. And so to check it, what we can do is we can plug it back in. So check, we're just going to go and put the square root of 3 times 12. And so that gives me the square root of 36, which equals 6, and we're good. Okay, let's try another one. So here again, if I look, I've got my square root isolated on one side, so I can square both sides. Because now my square root and my square are going to cancel, and so I'm left with x minus 4 equals 8 squared, which is 64. I'm going to solve this by adding 4 to both sides. And so x equals 68. And again, we want to make sure we check it. We're going to check it by just plugging it back in. So the square root, 68 minus 4, gives me the square root, 64, which is 8. Okay. All right, let's get a couple more. So example 3. So if we look again at thinking of our equation as being two sides, our square root is not isolated here. So we need to isolate that first. So we're going to start by getting rid of this minus 3. So I'm going to add 3 to both sides. So that leaves me, this cancels, and I've got square root 4x minus 3 equals 3. Now it's isolated. So I can square both sides. My square root and my square are going to cancel. And I've got 4x minus 3 equals 3 squared, which is 9. Can solve that by adding 3 to both sides. These are going to cancel. I've got 4x equals 12. Final step, I'm going to divide by 4. And so x equals 3. But we always want to make sure we check it. And when we check it, we're going to check it back in that original equation. And come back up here and I'm going to plug that in. So check. I'm going to put the square root 4 times 3 minus 3. Then I need to subtract 3 after that. So I've got the square root 12 minus 3. I've got the square root 9, which is 3. And 3 minus 3 is definitely 0. Okay, question 4. All right, so here I do not have a square root this time. I have a cube root. But we're still going to do the same thing. We still need to isolate on one side of that equal sign. So the first thing I'm going to do, I'm going to start out by getting rid of that 3. So I'm going to add 3 to both sides. So I've got a cube root, since I have it, of x plus 2 equals 3. Now it's isolated. So instead of squaring both sides, I'm going to raise both sides to the third power because I want to make sure that this exponent matches this index in order for them to cancel. So x plus 2 equals 3 to the third power, which is 27. Then I'm going to subtract 2, and x equals 25. I do want to show you in your calculator how to get the cube root if you're trying to check this using your calculator. So when we check it, we've got the cube root of 25 plus 2 minus 3. If you press the math key, and then you look down here, you've got a cube root here, but then this one also will give you any root. Okay, so if you press this number 4, it will automatically give you the cube root. So you can do 25 plus 2. Make sure you arrow out of your root before you do the minus 3. Okay, so we can definitely see that that works. The other one I do want to make sure I show you is this one. So over here, if you had any other root, this will let you type it in, but you can type in a 3, and then you would just type it just like you did there. So any root, it's right there, math, and then you scroll down and you've got those there. All right. Okay. Right, let's look at the next one. So here it says to solve. We've got our square root isolated, so I'm going to start by squaring both sides. And then this square root and square cancel. So I've got 3x equals negative 2 squared, which is 4. I'm going to divide by 3. And then I've got x equals 4 thirds. Okay, so then when I check it, I've got the square root of 3 times 4 thirds. That's going to give me the square root of 4, and the square root of 4 is 2. Okay, let's look. So I've got negative 2 versus 2. They are not the same. So this does not equal negative 2, which is what I need. That means this does not work. So there's no solution here. Doesn't mean we did the problem wrong. Just means it doesn't work. So it's called an extraneous solution. Okay. All right, let's look at another example. All right, number 6. So this one has 2 square roots. Okay, that means this one's going to be a little bit longer. Okay. All right, so is one square root isolated, right? So if that's my equation, do I have a square root that's by itself on one side? Yes, I do. So I can start by, color will stick out, squaring both sides. So I'm going to square that. I'm going to square that. Okay, so that means that this square root is going to go away. And so I'm left with 3x plus 1 equals, now here, if I square this side, what that means is I have to multiply it by itself. I can't square the pieces individually. I have to say that this is 3 plus the square root of x minus 4 times 3 plus the square root of x minus 4. That's where the work's going to come in. Okay, so we've got to make sure that we do this carefully. So I'm going to bring down the 3x plus 1 on the left. Now we're going to put in the work. All right, so I'm going to multiply 3 times 3. So I get 9. Then I'm going to multiply 3 times the square root of x minus 4. So I get plus 3 times the square root of x minus 4. Then I'm going to multiply the square root of x minus 4 times 3. So I've got plus 3 times the square root of x minus 4. Last thing I got to do is the square root of x minus 4 times the square root of x minus 4. All right, so that plus the square root of x minus 4 times x minus 4. So let's think about that for a minute. Okay. X minus 4 times x minus 4. Well, that's the same thing as saying x minus 4 squared. Well, a square root and a square are going to cancel each other out. So really, this is the same thing as just saying x minus 4. Okay, so all of this just becomes x minus 4. All right, so let's clean everything else up. So I've got 3x plus 1 coming down. I got 9. Now, these two have the same radical. Square root of x plus 4, sorry, x minus 4, and square root of x minus 4. I got 3 plus 3, so that's plus 6 square root of x minus 4. Okay? Oh, that is messy. Let me redo that. Okay? And I'm going to move these over a little bit closer. Okay. All right. So let me write that here so you'll have it for your notes. All right. So that just equals x minus 4. Now we can combine some like terms. So 3x plus 1. I can combine my 9 and my minus 4. So that's going to leave me with 5 plus 6 square roots of x minus 4 plus x. Okay, so remember at the beginning when we had our steps and I said if you still have a square root after you do the first time, we're just going to do it a second time. So what that means is I want to isolate on one side of my equal sign a square root. Okay, so let's move everything away. That means I want to move this 5 over here, and I want to move this x over here. So I'm going to subtract the 5 and I'm going to subtract the x. Okay, so I've got 2x, I've got minus 4, and over here I've got 6 square roots of x minus 4. Okay, all right, excuse me. So now I've got my square root by itself. There's nothing being added or subtracted to it. So I can square this, and when I do that, 6 square roots of x minus 4 squared, well, I still have to square that 6, and that's going to become 36. But my square root, that's going to go away. And I've just got x minus 4. On this left side, though, I do have to multiply that out. I have to write that 2 times. That we're going to have to work out. All right, so it's getting to be a long problem. I got 2x minus 4 times 2x minus 4. I'm going to take that 36 and I need to send that through. So 36x, 36 times 4 is minus 144. Okay, I need to distribute this. So 2x times 2x. So I've got 4x squared. 2x times negative 4, so minus 8x. Minus 4 times 2x minus 8x. And then plus 16. Okay, so I've got a quadratic equation. To solve a quadratic equation, we've got to get this equal to 0. All right, so I'm going to move up here so I've got some more space. I need to get everything on the left side so I can equal this to 0. So 4x squared is going to stay on the left. I need to combine all my x's. So here I've got negative 16x. I'm also going to move this 36 over and make that negative 36x. So I've got negative 16 and negative 36. So that's going to give me minus 52x. And I've got positive 16, and then I'm going to add 144 over. So that leaves me with plus 160. And now it's equal to 0. The reason we want to do that is so that we can factor. So if I look at all three of these terms, there's a GCF of 4. So if I take out the 4, I've got x squared. I'm going to divide that negative 52 by 4, and that leaves me with minus 13x. If I divide 160 by 4, I've got plus 40 equals 0. Okay, now remember, for factoring, we're looking for numbers that are going to multiply to 40 and add to negative 13. And those numbers are going to be negative 8 and negative 5. Because they're going to multiply to 40, but they're going to add to negative 13. Okay, so I've got 4, I've got x minus 8, and x minus 5. If you need a refresher on factoring, you can go back and watch that video. Okay, remember 4 equals 0. That doesn't make any sense, so I could throw that out. X minus 8 equals 0, and x minus 5 equals 0. That means that x equals 8 and x equals 5. So I've got 2 answers here. And then to check those, we would just plug them both back in to the very beginning. Okay, more like this. And I know that was a long problem, so if you need to go back and kind of rewatch it and slow it down, absolutely suggest that. All right, so in this one, We have one radical isolated, so we're going to start by raising it to the second power. So that gets rid of that side. This one, I do need to multiply that out. So I've got 73 minus x on this side. I'm going to get x squared minus x plus 1. I need to clean that up. Okay, so 73 minus x. I got x squared minus 2x plus 1. Sorry. I'm going to set it equal to 0. So x squared, I'm going to add that x over, so minus x. I'm going to subtract that 73, so minus 72. And now it's equal to 0. Okay? Again, we want to factor this. So again, if you forgot how to factor, you can always go back and look at those videos again. So I need numbers that multiply to 72, but add to negative 1. So if you want your table, they're going to multiply to negative 72. They're going to add to negative 1. So if I use 9 and 8, 9 times 8 is going to give me negative 72. I need them to add to negative 1, so I'm going to do negative 9, positive 8. So that means that 0 equals x minus 9, x plus 8. So then I've got x minus 9 equals 0, x plus 8 equals 0. And so x equals 9 and x equals negative 8. Okay. Again, we always want to make sure we check them. So we can do that in the calculator again if we want to. Okay. So we've got the square root. Okay, so second x squared. 73 minus 9. And that's going to be 9 minus 1. So that works. We get 8 and 8. We're good. Okay, let's try negative 8. So 73 minus negative 8. We get 81. Then we've got negative 8 minus 1. That does not work. Okay, so what that tells us is that we do not want to keep this answer. So we really only have one answer, which is 9. This one is called an extraneous solution. So you always want to make sure that you're checking your answers. Okay. All right. Let's get a couple more things. So Pythagorean theorem. If A and B are lengths of the legs of a right triangle, and C is the length of the hypotenuse, then A squared plus B squared equals C squared. So A and B are going to be the legs. They are going to form that right angle. The hypotenuse is going to be the side that's across from the right angle, and that's going to always be side C. Okay? So you're going to square A, square B, and add those together, and that's going to equal C. So let's use this to try to find some sides of triangles. So example 8 says use the Pythagorean theorem to find the unknown side. So here I've got the two legs that are given, and I know that they're going to be my legs. They're going to be my A and my B because they're the two that form that right angle. That means that C is the side I'm trying to find. So I'm simply going to set this up as 2 squared plus 3 squared equals c squared. And now I'm going to solve it. So 2 squared is 4. 3 squared is 9. 4 and 9 is going to give me 13. And to get that squared away, I'm going to square root both sides. So if I take the square root of that square, it will cancel. And so what that means is the square root of 13 is equal to c. All right, question 9. So this is going to be side A. Side B is the side that I don't know because C has to be the side across from the right angle. And the two sides make that right angle are going to be your A and B. So again, we're going to set that up as 4 squared, that's my A, plus B squared equals C squared. So the square root of 66 squared. Okay, so 4 squared, I got 16. If you square the square root, that cancels, so that equals 66. I need to solve for B, so I'm going to subtract 16. So B squared equals 66 minus 16, so 50. I'm going to square root both sides. So that means that B equals the square root of 50, but we always want to simplify. So that can be the square root of 25 times 2, which is 5 square roots of 2. Okay. Scott set up a volleyball net in his backyard. One of the poles, which forms a right angle with the ground, is 6 feet high. To secure the pole, he attached a rope from the top of the pole to a stake 4 feet from the bottom of the pole. To the nearest tenth of a foot, find the length of the rope. For problems like this, it is very important that you draw a picture. It doesn't have to be a fancy picture, but try to set up the shape. So it says, Scott set up a volleyball net in his backyard. One of the poles, which forms a right angle with the ground, is 6 feet high. So I'm going to draw the pole. I'm going to draw the ground. And it says it forms a right angle. So I'm going to draw that in. And it says that pole is 6 feet high. To secure the pole, he attached a rope from the top of the pole to a stake 4 feet from the bottom of the pole. So here's the top. This is the rope. Okay. And it says that he attached a rope from the top of the pole to the stake that is 4 feet from the bottom of the pole. That means that the 4 foot needs to go here because it wants us to find the length of the rope. That means that we need to find side C. That's the rope. Okay, so A squared plus B squared equals C squared. So 36 plus 16 equals C squared. 52. I'll take the square root. So the square root of 52 equals C. And it tells us it wants us to round to the nearest tenth of a foot. So in our calculator, we would put that. Calculator back up. So we would do second square root 52. And we're going to round that. So 7.2